Hi children, in previous class I explained what? Characteristics of wave. So nearly 6 characteristics of wave I explained. One is wavelength, frequency, and next time period, velocity of wave, and next one is amplitude, and next one is wave number. All 6 characteristics of wave I explained in the previous class. Right. So let's go to the next topic. Black body. Children, let us discuss about the black body. So what is black body? So black body is it is completely absorber and completely emitter. Completely absorber and completely emitter. Completely absorber. Absorber. Emitter. Completely absorber and completely emitter. That is called as black body. Completely absorber and completely emitter. That is called as black body. What completely absorber? What completely emitter? That means it absorbs all types of electromagnetic radiations. ఏంటంటే ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్స్ అన్ని అబ్జార్బ్ చేసుకోవడము లేదా అన్ని ఎలక్ట్రోమాగ్నెటిక్ రేడియేషన్స్ని ఎమిట్ చేయడమో జరిగితే కనుక దాన్ని ఏమంటారంటే బ్లాక్ బాడీ రేడియేషన్ అంటాం. ఇట్ ఈస్ కంప్లీట్లీ అబ్జార్బర్ ఆఫ్ ద రేడియేషన్, ఆల్ టైప్స్ ఆఫ్ రేడియేషన్స్, అండ్ ఎమిట్స్ all types of electromagnetic radiations. So what is electromagnetic radiation? Already in previous class we have discussed about that. So what is that? Cosmic rays, X-rays, gamma rays, UV rays, visible light, IR light, radio waves, microwaves, all these are electromagnetic radiations. If that black body absorbs all electromagnetic radiations, that is called as black body. It absorbs all types of electromagnetic radiations, and not only that, it emits all types of electromagnetic radiations. So absorbs or emitter. This is called as black body. Okay, na children? So black body. This is the definition. Let's go to in the nature. There is no black body, 100% black body, but few are there black body examples, but those are not 100%, only 99% only the black bodies. First one is examples of black body. Sun emits all types of radiations, cosmic rays, gamma rays, X-rays, UV rays, visible light, and IR. So all types of electromagnetic radiations it emits. All types of electromagnetic radiations, that is the example, black body example, sun. Next one is carbon black. Carbon black. This is the second black body example. Next, third one, holosphere. Holosphere coated with the platinum. This is the holosphere. Inside coated with the platinum block, which is having small hole on the wall. See, this is the holosphere. Inside coated with the platinum block, which is having hole on the wall, like this. So this is called as what? Third example of black body. So what I am telling? So holosphere, inside coated with the platinum block, which is having hole on the wall. This is called as what? Example of black body. These are not 100% black body, 99% black bodies. There is no black body in the nature. So okay na children? So these are the black body definition and examples. So here this is holosphere. hollow sphere inside coated with platinum block. Inside coated with platinum black, which is having small hole on the wall. So this is about the examples. So what I am telling here, black body definition means what? It absorbs all types of electromagnetic radiations and also emits the all types of electromagnetic radiations. Next example, sun, carbon black and hollow sphere inside coated with the platinum block and having small hole. So these are the 3 examples of black body. So let's go to the next topic. I will explain about the graph based on the black body. So let us discuss about the black body. Right. See, in order to understand the graph, so first let me tell the one example. So X, Y, Z, 3 temperatures are there. That is X ideal body, that is the black body temperature, that is X, that is 3000 kelvins I am taking, and Y, this is 6000 Kelvin, and Z 12,000, this is 12,000 Kelvin. These are the X, Y, Z black bodies having temperature X 3000, Y is 6000 and Z is 12,000. These are the 3 ideal bodies. Not black body is nothing but ideal body only. Ideal body not 100%, no, that's why I am taking. So ideal body. This is also ideal body. This is also ideal body. There is no 100% black bodies. Okay, 99% only. So I am taking here X, Y, Z black bodies. So first one I am taking the temperature at this particular temperature. So I am taking one ideal object, so which is heated at 3000 kelvins. Okay. So first what color it forms? I am heating this one. I am heating this one. Okay na? First it shows yellow color. First it shows which color? First it shows yellow color. Okay. Second it shows orange color. Orange color. Next it shows red color. So first, this is the iron object. This is the iron object which is heated. First it shows yellow color. Next it shows orange color. Next it shows red color up to 3000 kelvins. So it shows yellow color. Yellow. Next it shows orange. Next it shows red color. So here when temperature increasing, so this is 3000 Kelvin temperature. So when increasing the temperature again up to 6000 Kelvin temperature, then what happens? The intensity of these colors. When iron object I have taken, that is heated first at 3000 Kelvin temperature, yellow forms first, orange forms next red forms. Okay na? So this is next at 6000 Kelvin temperature. Just I am increasing the temperature. Okay na? From 3000 kelvins to 6000. First initially the brightness of the yellow color the brightness of the yellow color, what happens? Yellow color brightness increases, and orange also, intensity of the orange also increases. Next, red intensity increases. Next, 12,000 Kelvin temperature, what happens? Increasing the intensity of the color. So I am taking first yellow color, intensity increases. Next, orange, here red. So tell me what I am explaining here. So at different temperatures, different colors are formed. Here yellow, orange, red. At this time, first at 3000 Kelvin temperature, first it shows yellow, next orange, next red. When then this iron is heated, when iron is heated, first it shows yellow, orange and red. Then 6000 Kelvin temperature, then it shows yellow, orange, red. But the increasing the intensity here dull, it shows dull. Appearance is dull here. Here brightness increases. Brightness increases. Here full intensity, full bright. Here dull bright. Here dull bright. Here bright increases. Here full brightness. So what I am telling here, when you see the graph, in order to understand the graph, so you should know about this. When iron object is heated at 3000 kelvins, it shows yellow color, next orange color and red color, but dull in color this is. When you increase the temperature, then increasing the intensity, brightness, again increasing the 12,000 degrees, 12,000 Kelvin temperature, so that is increasing the brightness. So if you understand this one, I can say the graph easily. Okay now children? So let us discuss about the black body. So black body is nothing but ideal body. There is no perfect black body in the nature. Okay, so that's why I am taking ideal body. So what is that ideal body? Carbon black. Next, holosphere inside coated with the platinum black, which is having hole. These three sun also. These are the three examples. But sun we are not taking. Yes or no? Sun already it is there. Okay. But we are taking carbon black and holosphere inside coated with the platinum black, which is having hole on the wall. So this is about the black body. So to understand the graph, you should know about this. Right children? Let's go to the next graph. See the graph here. So a graph drawn between the intensity versus wavelength. A graph drawn between the intensity versus wavelength. Here 3000 Kelvin temperature. See here the wavelength, see here. First slowly increases, again increases only. This is the wavelength. But see the 3000 Kelvin temperature, 6000 Kelvin temperature and 12,000 Kelvin temperatures. What happens? The increasing the brightness of the graph. See I am taking here a graph drawn between the intensity versus wavelength. See here, first graph will be like this at 3000 kelvins. Second graph will be like this, and this is 6000 kelvins. Next one more graph, that is 12,000 kelvins. This is intensity, this is what? Wavelength, lambda. Now graph drawn between the intensity versus wavelength using the temperatures. So first what I have taken at 3000 kelvins, yellow, orange, red. Yellow, orange, red. Here wavelength of the, see in order to understand this one, VIBGR VIBGYOR, VIBGYOR. See here, VIBGYOR, VIBGYOR. VIBGYOR is nothing but what? Light. Light, you know, light. Here visible light is there in electromagnetic radiation. Visible light. Visible light. Yes or no? Visible light which is having VIBGYOR. VIBGYOR, VIBGYOR. Yes or no, children? VIBGYOR is there. So left side this is violet color, right side this is red color. So what happens, the wavelength here, violet color wavelength is less. Here lambda is less. Lambda is less. And red is more. Red is more wavelength. Red is more wavelength. Lambda is more for red. So wavelength which is more, red. So here I am taking YOR. What is that? YOR. YOR. What is this, Amma? YOR. Violet, orange, red. So violet, orange, red, which is more wavelength, red is more wavelength. Which is less wavelength, yellow is less wavelength. Here see once in this graph, here wavelength. In this graph, see once, this is the VIBGYOR light. Yes or no? Light is present here. Okay, at 3000 Kelvin temperature, see that wavelengths, yellow color, orange color, red color. Here wavelength is less. Yes or no? Now increase the temperature, 6000 Kelvin temperature. Now what happens, the intensity, here intensity increases, here intensity decreases. Here brightness is more, here brightness is less. Intensity is more here. Okay, but yellow, orange, red, yellow wavelength is less, red wavelength is more. Okay, here intensity is more, 6000 Kelvin temperature. 6000 Kelvin temperature, intensity is more. Okay na? Wavelength of yellow is less, but the increasing the intensity increase అవుతుంది ఎప్పుడు టెంపరేచర్ ఇంక్రీజ్ చేస్తే. ఓకేనా? వేవ్లెంత్ దాని యొక్క బ్రైట్నెస్ని బట్టి ఇక్కడ ఎల్లో వేవ్లెంత్ తక్కువ ఉంటుంది. ఓకే, ఆరెంజ్ వేవ్లెంత్ ఎక్కువ, రెడ్ వేవ్లెంత్ ఎక్కువ. సో బికాస్ ఆఫ్ దిస్ VIBGYOR ఎక్కడుంది, ఇది లైట్, విజిబుల్ లైట్. ఆ విజిబుల్ లైట్ లో VIBGYOR, VIBGYOR అంటే ఏంటి, ఇది విజిబుల్ లైట్. లెఫ్ట్ సైడ్ అంటే ఇట్స్ విజిబుల్కి లెఫ్ట్ సైడ్ ఏముంటుంది, యూవీ అంటే ఏంటి, యూవీ రేస్ అంటే ఎనర్జీ ఎక్కువ ఉంటుంది, అంటే ఫ్రీక్వెన్సీ ఎక్కువ. ఫ్రీక్వెన్సీ అంటే దీనికి ఎక్కువ ఉంటుంది కదా, వైలెట్కి ఫ్రీక్వెన్సీ ఇటు సైడ్ ఉన్నదానికి ఫ్రీక్వెన్సీ ఎక్కువ ఉంటుంది, ఇటు సైడ్ ఉన్నదానికి ఫ్రీక్వెన్సీ తక్కువ ఉంటుంది. ఫ్రీక్వెన్సీ ఇటు సైడ్ దానికి ఎక్కువ ఉందంటే వేవ్ లెంత్ ఎలా ఉంటుంది, తక్కువ. ఇలా వెళ్తుంటే వేవ్ లెంత్ స్లోగా ఇంక్రీజ్ అయింది. కానీ ఎల్లో, ఆరెంజ్, రెడ్ నేను తీసుకున్నాను, ఎల్లోకి వేవ్ లెంత్ తక్కువ. దేనికంటే, ఆరెంజ్ రెడ్ కంటే. ఎల్లో వేవ్ లెంత్ తక్కువ దేనికంటే, ఆరెంజ్ రెడ్ కంటే. సో ఇది తీసుకున్నాను, ఎక్కడ తీసుకున్నాను నేను, 3000 Kelvin టెంపరేచర్ దగ్గర తీసుకున్నాను. ఎల్లో, ఆరెంజ్, రెడ్, ఎల్లో, ఆరెంజ్, రెడ్, దీని వేవ్ లెన్స్ తక్కువ. ఓకేనా? కానీ బ్రైట్నెస్ చూడండి, వేవ్ లెంత్ ఏమి చూడండి ఒకసారి, వేవ్ లెంత్ ఎక్కడ ఏమన్నా చేంజ్ అవుతుందా, వేవ్ లెంత్ ఈ ఏరియాలో చేంజ్ అవ్వట్లే. సో ఇంటెన్సిటీ మాత్రం ఇంక్రీజ్ అవుతుంది, ఇంటెన్సిటీ ఇంక్రీజెస్. సో దిస్ ఈజ్ ద గ్రాఫ్. సో బ్లాక్ బాడీని లేదా ఐడియల్ బాడీని తీసుకొని దాన్ని హీట్ చేస్తే డిఫరెంట్ టెంపరేచర్స్ దగ్గర డిఫరెంట్ కలర్స్ని ఎగ్జిబిట్ చేస్తుంది, ఎల్లో, ఆరెంజ్, రెడ్ అలా తీసుకున్నాను నేను. ఓకే, అప్పుడు ఇంటెన్సిటీ ఏమవుద్ది, ఇంక్రీజ్ అవుద్ది అట్ డిఫరెంట్ టెంపరేచర్స్. సో థ్యాంక్ యూ చిల్డ్రన్. సో టుడే ఐ ఎక్స్ప్లెయిన్డ్ అబౌట్ వాట్ బ్లాక్ బాడీ ఎగ్జాంపుల్స్, నెక్స్ట్ విత్ క్లియర్ ఎక్స్ప్లెనేషన్ ఇన్ ఏ గ్రాఫ్. ప్రతి ఒక్కరు కూడా ఈ కాన్సెప్ట్ అందరూ నేర్చుకోవాలి. దీని మీద IIT క్వశ్చన్స్ వస్తాయి, చాలా ఇంపార్టెంట్ కాన్సెప్ట్. ఈ గ్రాఫ్ మీద చాలా ఇంపార్టెంట్ క్వశ్చన్స్ ఉన్నాయి. సో డిఫరెంట్ టెంపరేచర్స్ దగ్గర ఇంటెన్సిటీ ఏమవుద్ది, ఇంక్రీజ్ అవుద్ది అని అలాంటి క్వశ్చన్స్ ఉన్నాయి. సో కాన్సెప్ట్ క్లియర్గా నేర్చుకోండి. థ్యాంక్ యూ.